This is a demonstration of the Microbit working. That is the startup process. And then you hit A to give the thing to start writing the readings to memory. This is using the accelerometer to measure the X and Y and Z planes. And then you can hit the B button to stop writing recordings. And then I also built in a wipe record as well. That gives some visual feedback and lets you know that the memory, onboard memory, has been wiped. And then the data is, as I said, right. It's written to on device. So right now it's accessed back on the computer under my data HTM. And a couple things that we'll go over in the code here, but first thing, it does set our table, our column names for our table. And then this is something that I built into the code. This is that initial startup reading that we take, and we have it, and we created this fifth column to kind of designate when we have these, what I'm calling reference readings. And what we do, what I basically, why we came up with this was we were having trouble initially designating or kind of figuring out when we had a different set, recording, we'd record sets of reps, and it was hard to figure out, looking through all this, like, okay, well, where does one set end and where does one end start and where does one end? And so that's why we built in this reference read, so that we know now when we see this reference reading, that's the start of a new set. So that kind of helped us build out a visual kind of designation in the data to allow us to see when one set ends and when the other one ends. And we can go out into that a little bit further in the code. All right, I'm going to try to be very quick so I can stay under time here. One of the requirements was to have 2 loops in the program. Hopefully this is a valid use of that. This is the nested loop that's going to run, that's running that's our diagnostic function. Basically just runs through all of the LEDs, make sure everything lights up, and then we've got multiple decision structures, but within this function, we have one that basically is just checking to make sure that our accelerometer readings are within a normal range. This kind of takes this strength is a combination of all of the X, Y, and Z. Gives visual feedback that if everything's good, and then know if it's bad. As you can see, we have a multitude of functions being used. So we've met that requirement, and I believe there's some more decision structures down here. We also used, this is a memory on full function that I wrote to make sure that we get visual feedback, visual and audio feedback when the memory has been maximized. We've reached a maximum amount of memory and we can't record any more readings. So that is why this is in there. If it's logging is active, the theory is I'm under the bar, so I need to both see and hear a warning. Otherwise, we just give a visual warning. Again, another function here. This is the built-in main function. Do have another decision structure here that if our tripwire, basically our logging active tripwire, is functioning, what this does is kind of make sure that the readings are within an acceptable range. And if they are, we go ahead and call the log function and mark it as a sample. These are the built-in input listeners that listen for what happens on device, and then it's set to call the functions that I've written. Our startup check function obviously needs to run before we get into checking or taking recordings and readings, just to make sure that everything is good to go. I am going to stop it there and hopefully provide a little more detail in writing and in person.